Let's take a look at the indefinite integral of the following vector function. Components are t squared, and then 2 to the t, and then cosine of t. So we should basically just take one component at a time and take an antiderivative. So I could have written in the angle bracket notation, but these angle brackets would have just looked huge just due to these fractions. So I just did this in IJK notation. But you antidifferentiate t squared to be a t cubed over 3. Don't forget a c. Don't forget a constant, right? Plus c. 2 to the t should antidifferentiate to become 2 to the t over ln of 2. Don't forget a c. Oh, but you see this constant doesn't have to be the same as this constant. And then antidifferentiate cosine of t to be sine of t plus a third constant called c sub 3, I guess. I mean, you could call, if you don't like the subscripts, the constants could be c, d, and e, all capital letters or whatever. But since all three of these are constants, what we could actually do is rewrite this as a vector plus another vector, where this vector c happens to have components c1, c2, and c3 from above. So this is a constant vector. I mean, this is a vector with no t's in it, right? These are just numbers right there. And so because c is a constant vector, I mean perhaps c is the vector 6, 7, 8 or the vector 9, 9, 7, 8. The whole point is when you just like back in Calc 1, when you antidifferentiate, you're trying to undo the derivative, and if you differentiate a constant, you get 0. Just like this, right? If you were to differentiate the vector 6, 7, 8, well, there's no t's in any of the components, so 6 is going to differentiate to 0, 7 is going to differentiate to 0, and 8 is going to differentiate to 0, right? Because you differentiate one component at a time. Okay, so we just saw the following is an antiderivative. Just this is the if you look at this, there's many antiderivatives. You actually have so many just based on being able to pick any number you want for C1, C2, and C3, and they could be different numbers or the same number or whatever. So one of those antiderivatives is just the one where the C vector is 0, right? So t cubed over 3, comma 2 to the t over ln of 2, comma sine of t, that is an antiderivative of the vector function t squared 2 to the t cosine of t. So here's the work for the indefinite integral, completely written out. Sorry, without the work, but at least just stating what the final result is. And so if you were to borrow this antiderivative that's right here to find the definite integral from 0 to pi, well, it's these differences as you're used to, right? So take the first thing, t cubed over 3, and we should evaluate both at pi and at 0 in that order, and then same deal for all of the components. I went ahead and did what simplifications I really could here. To some degree, just reminder that sine of pi is equal to 0 and so on. You could simplify this a little further, and I guess I haven't here. Okay, let's find the definite integral from 0 to 1 of r of t dt, where r of t is 2 over 1 plus t squared, and then 2t over 1 plus t squared, and 1 over t plus 1. This question, I think, will be a good review of some integration rules that might have become a little rusty, let's say. And we won't do a whole lot of integration until chapter 15, but let's just get ourselves some reminders of how this goes. So you may recall that 1 over 1 plus t squared is a standard antiderivative. It's arctangent of t, and so we just have 2 times that. For the next one, I didn't show all this work here, but antidifferentiating 2t over 1 plus t squared is going to be a basic u substitution where u is going to be 1 plus t squared. And then in the same vein, antidifferentiating 1 over t plus 1 should also be a u substitution where u is equal to t plus 1. Okay, so then that's the indefinite integral. Oh yeah, don't forget your plus c. It's a c vector though. Then the definite integral from 0 to 1. So we need to take the 2 arctan t both at 1 and at 0, and so on and so forth. So let's just now talk through some of the simplifications here. These are some good reminders. Arctangent of 1, remember, just means tangent of what angle is going to be 1. and that's your 45-degree angle, your pi over 4. Um, Tangent of what angle gives you this 0 here, and that is going to be this 0. So this 0 is in radians, and this 0 is this 0 right inside the parentheses here. This 0 right there inside the parentheses is a value of tangent. It's an output of tangent. Okay, so that's 0. Let's see, we have here ln of absolute value of 2 minus ln of absolute value of 1. And I guess same deal here, ln of 2 minus ln of 1. And ln of 2 really doesn't simplify any further, but ln of 1 is 0, right? So yeah, e to the what equals 1, and that would be a 0. So it's just ln of 2 as the second and third components.